you have to remember the snowman, right? Whenever they ask you anything about atomic radius, remember snowman, and then radius increases, the size increases down a groove and decreases across a period. Think of the snowman, he toppled over, all right? The trend, if you draw this, is very obvious. The question is why, all right? We'll discuss that in 3, but can somebody help me with number 2? So when they say decreasing atomic radius, do they mean bigger to smaller or smaller to bigger? Bigger to smaller. Which is the biggest one of all these atoms? Cesium is bigger than, what do you have next? Vanadium is bigger than, silicon is bigger than fluorine. So the order matters, all right? Now, explain why atomic radius decreases across a period. Why does it become smaller as you go across a period? All right, what will you say? Yes, Claudia.
So the nuclear charge of an atom increases while going across it.
All right, nuclear charge increases. All right.
Since there's more protons, they need a stronger pull because it's like a magnet.
Nuclear charge increases. Okay. There is.
So the protons pull in the electrons, therefore making the radius smaller since there's more of them.
So Claudia has talked about the number of protons, which causes the greater pull, which causes a decrease in the size. I agree 100% with her, but it will always say state all reasons. What is it that she did not talk about? Anybody in class? What did she not discuss? She did not talk about shielding effect, all right? You have to say nuclear charge increases while what remains constant? While shielding effect remains constant. While shielding effect remains constant. All right? Nuclear charge increases while shielding effect remains constant, and this causes an increase in pull of valence cloud, right? An increase in attraction, which is nothing but pull for valence electrons. I'm going to abbreviate valence electrons, VE, causing a decrease in the size. Does that make sense? Okay, who would like to try number 4? Why does the atomic radius increase down a groove? Yes, Natalie. And hence? And it becomes bigger, right? She has it all down. I give her all credit, all right? She could have just introduced the word that the shielding effect increases, so does the number of protons. But the dominating factor is the shielding effect, which decreases the effective nuclear charge, causing an increase in the size. While shielding effect and nuclear charge increase down a groove, shielding effect dominates. Shielding effect is the dominating factor, causing a decrease in effective nuclear charge. Hand size increases. Hand size increases due to decreased attraction or pull. Slash pull. Are we good? Does that make sense? So I'm not really looking forward to you writing each sentence. One should be the first one, the second you can talk about nuclear, effective nuclear charge first or shielding first. You can talk about the number of protons next. I don't care about the order as long as you state it correctly. Like I was telling Natalie, you shouldn't tell me the number of protons are increasing, hence the size is increasing. Does that make sense? They don't correlate with each other. If the protons increase, the size should decrease. Is that right? You can't tell me shielding effect increases, hence size decreases. That's just not right. Does that make sense? That means you're not understanding the underlying factor. Okay. Okay. It's not aligned. So let's move down. Okay. And let's look at the first question. So I had given the frequency as 76 second inverse, not hertz. Alright? Why did I purposely give it in second inverse? Second inverse is nothing but hertz. The reason is I would like you to know how units cancel and how you arrive at the answer. The speed of light is 3.00 times 10 to the 8 meters per second equals lambda times frequency, which is 76 second inverse. Yes or no? What does that tell you? Second inverse cancels on both sides. So what will your wavelength be in? Meters. Alright? So that was the reason why I gave it in meters. So what is your wavelength in meters? Anybody? What was the answer to this? Yes, Rohina?
In meters, right?
Yes. I would like it in sig figs, like maybe 2 sig figs. In scientific notation, anybody in class? It just helps me do the problem better. Yes, Lena, what is it?
I got 3.94 times 10 to the 6, but like other people got slightly different answers.
10 to the 6?
Yeah.
And this will be in what units?
Meters.
Meters. Alright, she's given 3 sig figs, that's okay. Did you get something very different from this? Yes, Mary Walton.
The answer is supposed to be in nanometers.
Okay, we're coming to that, alright? So the reason is, we are only left with meters. This is in meters. You have to be cognizant of these aspects when you solve problems. So the question is now asking you to give it to you in nanometers. Is that right? And you know that 1 meter is 10 to the 9 nanometers. Is that right? So this is a really, really, really long wavelength. Is that right? So let's see what is the answer. It's 3.94 times. You can add up the powers, right? 10 to the 15 in nanometers. My God. Even wavelength of visible light is only in the hundreds, like 700, 400 to 700, right? This is like so very long. Is that right? Because maybe it doesn't even exist in nature. Right? Okay, let's move on. For the next question, the wavelength is given in nanometers. Are you paying attention to the fact that it's in nanometers? If it's in nanometers, can you substitute it in the equation C equals lambda nu? Is it possible? So what should you convert it into? Meters. So remember last class we did this? Times 10 to the 2 nanometers. Is that right? right? So we did 10 to the 9 nanometers equals 1 meter. Is that right? Which makes it what? -7 in meters. Is that right? Correct? Now I'm ready to substitute in this equation times 10 to the 8. This is meters per second. And my wavelength is 4.10 times 10 to the -7 in meters. I'm solving for frequency. Meter will cancel. 1 over seconds is in frequency. So you divide both sides. Is that right? Correct?
Yep.
And so pretty much you're adding. 8 negative of -7 is adding. 8 plus 7. Is that right? So what is the divided by number? 3 divided by 4.10. Anybody in class? What is the answer? What did he get? 7.3 times 10 to the 14. This is in hertz. Correct? Any questions? Are we understanding the problem? Yes, Raphael.
So, I have a question about like the 4.1,
Uh-huh.
the 7.
-7. Not just 7. -7.
Why is it like -7?
Because this 10 to the 9 is in the denominator. If I take a number in the denominator and make it a power, how do we write 1 by 100? Basic algebra. It's 1 by 100 is 1 by 10 to the 2, which can be written as 10 to the -2. Basic algebra. Yes or no? Right? You should know basic algebra in this class. Yes.
So when you solve,
Like using the speed equation, you need to put it in meters because the speed is.
Very good. Speed is in meters.
Down and put in nanometers.
If they ask, yeah, most of the wavelengths around us are so small that we report them in nanometers, but you can't find one from the other unless it's in meters, because you're using the value speed of light in meters. Yes, Ravina.
what if I converted like the 3.0 times 10 to 8?
Oh, you can do that. You can do that. As long as you keep units the same, you're fine. So that will be really big, right? So 3, 10 to the 8 times 10 to the 9, right? So we can use that. Sure. All right? Yeah, yeah. If you keep units the same, the answer is going to remain the same. That's the whole fundamental, right? Okay. But this is not the end of the question. You only solved one part of the question. This is just the frequency. They've also asked you to calculate the energy of one photon of this wave. So what equation will you use? What is the second equation? E equals h nu. Well, Miss Darky was able to give the quiz. I'm a little bit more slower than her. E equals h nu. So value of Planck's constant is always given to you. Alright? I know I gave you 6.626. Can be written as 6.63 also. Correct? Times 10 to the -34. Right? Joules second. Times what is your frequency? 7.3 times 10 to the 14. So you just put these numbers in your calculator and you multiply. What do you get? 4.8 times 10 to the -19 joules. Because this is 1 by second. Frequency is nothing but 1 by second. Second on the same side. Numerator, denominator will cancel. Correct? Second and numerator on both sides will cancel. But on the same side, it has to be numerator and denominator. Correct? Basic math again. Okay. Let's go to the other side. Now, this is the concept of how we see colored light. Is that right? So, if you look at this transition, is energy being absorbed or released? Absorbed, because this is your ground state, correct? Not these nucleus, guys. It's a little not, board is not aligned. The first energy level is your ground state, correct? So it's going up. It's moving further away. Means it's going to higher energy level. So an up arrow means it is absorbed, correct? Right? Look at these two. Is the arrow coming down closer to the nucleus? Correct? Whenever it's coming closer to the nucleus, it's coming to a lower energy level. Is that right? And as it's coming down, it's releasing its extra energy. Is that right? So in transition, these two, A and B, the energy is being released. So which transition releases a wave with more energy? A. Because of the height. Look at the height. They're both coming to energy level 2. Is that right? But one is coming all the way from 5. The other one is coming from 4. So transition A has more energy. How can you tell? It's a bigger jump. Yes or no? Both transitions are going to 2. Both are coming down to 2. Coming down to energy level 2. But which is a higher transition. But A is, what is A's transition? 5 to 2. Is that right? Therefore, it's higher in energy. So if it's higher in energy, which releases a wavelength, which releases a higher wavelength? What is the correspondence between energy and wavelength? Greater the wavelength, lower is the energy. So they want one with greater wavelength. Which one will have a greater wavelength? A or B? B. How can you tell? You should say the energy is lesser, therefore its wavelength has to be longer because they're inversely related. Does that make sense? Any questions? Do you have any questions? Not on this part? Okay, predicting products. I think we did this, we moved on, alright? We didn't come back to this at all. Doesn't mean you kids don't practice. I think practice sheets were given out. I don't know if you practiced. I do have this. Was this sheet given out in class? Predicting products practice sheet? This one also? Was it ever given out? Was given out? This was all extra practice for you kids to do. Anyway, if you don't have it, you should find a copy on Blackboard, I think. Alright, I'll double check also. Alright, now, all of you remember we did solubility chart? Remember this? Do you remember this? You should have this. You will be provided this for the test. When do double replacement reactions take place? A double replacement reaction will take place with the product, not reactant. Are you listening? A double replacement reaction will take place if the product is what? Product is a solid, liquid, or a gas. Which side? Not reactant side. I'm talking about product side. How will you know a product is a solid? What will you use? You will use the solubility chart to find out if the solid is formed on the product side. The only liquid you should know of is water. Anytime you mix water on the product side, the reaction will happen. Alright? What are the gases? You can get gases like carbon dioxide, sulfur dioxide. These are gases. Anytime you get the formation of a gas, or hydrogen, or oxygen, right? These are elements that are gases, correct? You should know nitrogen, oxygen, fluorine, chlorine, all these are gases, right? The only compounds you should know of gases, carbon dioxide, which is pretty common, right? And sulfur dioxide, I don't think we'll do sulfur dioxide examples in this class. Are we good? These are gases. So if any of this is formed in the product side, the reaction will happen. Now let's look at the first question. This one says, formula writing. the quiz. I will give the quiz back next class. Few kids haven't even taken the quiz. Formula writing, memorizing polyatomic ions, you really have to study those. Kids are not good at formula writing at all. Hydrogen sulfide is a gas. Now, oh, the gas is on the reactant side. Will the reaction happen? Can I decide based on reactants? I should look at the product side. Plus lead to nitrate. I don't know if they remember how to write their polyatomic ions. Lead's charge is given as a Roman numeral. Now, what is the switch? Alright, the switch has to happen like this. Remember the inside out mix? Is that right? Remember a double replacement reaction? Yes or no? So one of the products is hydrogen nitrate, alright? And hydrogen nitrate, hydrogen is a +1, nitrate is a -1, alright? So that will be hydrogen nitrate plus lead sulfate, lead sulfide. Lead is a +2, sulfur is a -2, giving me lead sulfide. Alright, I switched the reactants and made the product. Will this reaction happen or not? I'm looking at my solubility chart. Alright, I'm looking at nitrates. Remember, I look at the second half first. All nitrates are soluble. What was the first half of nitrate? Hydrogen. Alright? Is it silver for me to say it's a solid? This side is a solid, right? This side is aqueous. It says there. This is a solid. That is an aqueous. So hydrogen nitrate will be a aqueous substance. What was my other product? PBS. Right? Is the other product PBS? Sulfide. I will not look at sulfides or sulfates. You should know the difference between a sulfide, and a sulfide. Correct? That was an ide. So I'm looking at my S. It says it's a solid. Then I'm looking at my PB. Is it group 1? Is PB in group 1?
No.
Is PB in group 2? Is PB ammonia? No. So what is PBS going to be? Solid. So my PBS is a solid and this is an aqueous. Did I get the formation of a solid on my product side? Will the reaction happen? Yes, this is a reaction that will happen. Alright, you just balance the equation by putting a 2 there. Is that right? Can we move on to the next question? Alright, a saturated solution of barium hydroxide is mixed with nitric acid. So let's write barium hydroxide formula plus nitric acid or HNO3 or hydrogen nitrate because we haven't done acids yet. Alright, so I'm mixing up the insides out. Are you with me? So I get the formation of, give me a minute, Claudia. Let me finish and then I'll take your question. Alright? Plus, what is HOH? Does H combine with OH? What is HOH? Water. Yes or no? Yeah? Is HOH water? What is water? Liquid. Will this reaction happen? Yes, you will get nitrates. If you look at nitrates on your solubility chart, alright, all nitrates are soluble except silver. You will get that other one to be aqueous. But you have to know that water is a liquid. Don't go and compare hydroxides if it is water. Does that make sense? Don't look at hydroxides on your chart. That will completely trip you over. Because you'll say, oh, hydrogen is with the group 1. You get that wrong. Water is a liquid. Alright? So this reaction will happen. You can balance the equation. Alright? Let's look at the next one. This is a hard one. This is a difficult one. Yes, Claudia, sorry.
Whenever there's just like
You should know to recognize what type of reaction it is,
Yeah.
right?
Yeah.
Among the different types. I'll come to single replacement one also. Solid titanium 4 carbonate. Alright? This is titanium 4 carbonate is reacting with hydrochloric acid. Carbonates. Remember in the lab you heated copper carbonate? How many of you had a discussion on copper carbonate? Did the reaction happen or not? Did the carbonate give off a gas? It was green colored powder. Do you remember that reaction? What happened, Aaron? It put the flame. So gas did evolve. It put the flame out. That's a very special trait of any substance that's a carbonate. If you have a carbonate on the reactant side and you're heating it, or even otherwise, carbonates tend to decompose very quickly. What do you think carbonates will decompose into? Carbon dioxide. So if you look at this reaction, it's really interesting. Alright? Kids will say it's titanium 4 chloride. So, alright, that's one of the products. And the other product is H2CO3. Carbonate is a -2, hydrogen is a +1. And the kids will look at their solubility chart. This will be aqueous. This also will be aqueous. Group 1 carbonates are soluble. And so they'll say hydrogen is in group 1. They will conclude this reaction doesn't happen. But is that true? What is the problem? This is a carbonate still. Is that right? So what will this break? So this is a double replacement reaction. Do you see that? But it doesn't stop. The double replacement reaction goes further down and becomes what? The carbonate breaks down into water and carbon dioxide, which is both the formation of a liquid and a gas. So if you conclude this reaction will not happen, will that be a correct conclusion? No. Alright? This is also called carbonic acid. Hydrogen carbonate is also called what? Carbonic acid. When you drink soda, they bubble carbon dioxide into it. Alright? What does that become? It's actually carbonic acid. The minute you open a soda can, what happens? What is happening? The carbonic acid is breaking down into carbon dioxide again. Everyday life. You see that? Every time. Ask your parents. I'm sure they won't remember. Alright? What's coming out? Alright? Carbon dioxide. Alright? Remember this. Carbonic acid is a very weak acid. So this reaction will happen. It's not balanced. Let's say I add copper to water. Oh, it's so funny to see this. What type of reaction is this? Single replacement. Alright? In order to predict if a single replacement reaction will happen, what do you look at? The activity series. So copper is the male, hydrogen is the male. Remember that? It has to be a more active male. Remember that? Yeah. Let's find out who's more active. Hydrogen or copper? What do you think? What do you think? Hydrogen is, so do you think hydroxide will leave hydrogen's company and go with copper? No, not happening, correct? Copper is below, hydrogen is above. Hydrogen is more reactive, correct? Okay, so there should be no reaction. Is that right? Guys, if I use common sense, do I really have to look at the metal activity series? Have you put copper in water before? Do they react? Did I really have to look at the metal activity series? But just because we learned, look at it. But it's common sense, right? Copper won't react with water. Yes. It will react with the oxygen in the air. Statue of Liberty has become green. Alright? But just take a piece of copper and put it into water. There is no fizzing, bubbling and all that. Right? Yes.
For number 3, would you like us to write it as H2CO3 and then have the arrow pointed down to show that it's two separate? Or would you
Wait. It's not H2CO3. First of all, copper is the metal.
No,
Plus,
for the number 3.
for what? For 3, what do you want?
That one. Would
Oh, you can
rather
write this
how-
TiCO4 plus H2O
Oh,
plus CO2 looks good too.
so you'll take it either
You
way?
can, I'll take it either way.
Okay.
But as long as there's a reaction.
And it should be balanced.
Okay.
Okay? Are we good? Okay, let's look at the last reaction. Okay, now let's look at the last reaction. Fluorine is passed through sodium bromide. Two females. It's a single replacement reaction. Which is the more active female, fluorine or bromine? Look at your metal activity series. Tell me. Well, Claudia, this is between fluorine and bromine. Only one male. Two females. Where is it given? On the side. The only activity series we look for girls is the halogens. Is that right? Or the non-metals. What does it say about halogens? What happens to reactivity of halogens if you compare fluorine, chlorine, bromine, iodide? Decreases. So which is more active non-metal, chlorine or bromine? Decreases. Which is more active, chlorine or bromine? Chlorine is more active or more reactive. Will the reaction happen? If chlorine is more reactive than bromine, will it be able to steal sodium away? Will the reaction happen? Yes, reaction happens. So you do get sodium chloride plus bromine is liberated. Is that right? Well, this will be a gas. That will be an aqueous because it says solution of, correct? And all chlorides are soluble. That will be an aqueous. And bromine is a liquid. The equation is not balanced. Do you see that? Are we good? Okay. The next one, the next page is the activities, the potential energy diagrams, right? Okay, I can't scroll down. Okay.
Sodium added to silver nitrate.
Will the reaction happen? Sodium added to silver nitrate. Sodium plus silver nitrate. Sodium is higher up in the metal activity series, correct? Sodium is the more active male, so the reaction will happen. NaNO3 plus silver will get deposited. Are we good? Okay, let's go to the next page. Potential energy diagrams. Is this endo or exo?
Exos.
It's an exothermic reaction. Which letter represents the potential energy of the reactant?
E.
B. Which is the potential energy of the products?
F.
F. How do you calculate, or which is the heat of reaction? Is it product minus reactant? This is delta H, by the way. All right? So which is the difference between these two?
D.
It's going to be D. What is the activation energy?
A.
A. What is the activation energy for the reverse reaction?
Negative E.
Negative E, very good. Well, activation energy is always positive. Heat of reaction is positive or negative. It's always the energy that you have to provide. So it is the energy going in, right? It is an endothermic. In order to break bonds, it is endothermic. What represents the energy of the activated complex? Okay, I can't see it anymore. Maybe you guys can give me the answer. Is the reverse endo or exo? The reverse is endo. If a catalyst were added, what letter would change? The activation energy would change. right? And you know to draw the effect of a catalyst, right? Right? Okay. We have how much more time left? 8 minutes. So, can I just make it a homework grade and give you the quiz and let you take it home? And all of you need to turn it in? Alright. Okay? So guys, I know kids love this idea. I know it's low stress. But here is my stress with it. Unless I force you to learn and tell you you're not learning, you don't tend to prepare for the test. Unless you take this assignment real seriously and do it on your own by studying all this and taking it as if it were a quiz, it's going to do you no good. Is that right? If you just ask somebody or fake it, then you're going to do really poorly on the test. Right? When did I stop recording? Oh, I didn't. Oh, here I'm